in this circle sum here, they have mentioned Seg AB is a diameter. That means center O lies on AB. Seg CA and DJ, Seg CA and DJ are tangents to the circle. So AB is a diameter, Seg CA and DG are tangents to the circle. We are supposed to prove AJ is equal to CJ. Segment AJ is equal to segment CJ. For this, we'll need some construction part. First construction is OD you have to join. So I'll write here join OD, comma. We have to join even DA. DA. Okay? So we are joining this in OD and D. So in triangle ABC, AB is a diameter. So measure angle BAC will be equal to 90. Reason, radius perpendicular to tangent. Radius perpendicular to tangent. Now, measure angle BDA is equal to 90 because Seg AB is a diameter subtends angle BDA on the circle. That is diameter property. Seg AB is a diameter which subtends angle BDA on the circle. Okay. Now, if I apply linear pair property, third point, measure angle BDA plus measure angle BDA plus measure angle ADC. Measure angle ADC. This will be 180 by linear pair. Out of this, BDA is 90. 90 plus measure angle ADC is equal to 180. Therefore, angle ADC is equal to 90 degree. Because if I take 90 on that side, 180 minus 90, I'll get angle ADC is equal to 90. Now, point number 4. In triangle JAD, Seg JA is congruent to Seg JD. This is tangent segments drawn from external point. Therefore, this happens to be triangle JAD happens to be isosceles triangle. Hence, what I'll get is measure angle JAD is equal to measure angle JDA is equal to x degree. This is isosceles triangle here. Point number 5. Please observe properly. This is a tangent and this is secant. So there is an angle which is formed by a tangent and a secant. Can you see? Now this angle is half of this arc AD. In the same manner, angle ABC is an inscribed angle. So even that angle is half arc AD. So this angle here, JAD is X. So angle ABD also will be X by the theorem what is known as alternate segment theorem. So angles in alternate segments. So what I get is measure angle JAD is equal to measure of angle B, and that too equals to X degree. Reason, angles in alternate segments. Angles in alternate segments. Now, if we enter the large triangle, in triangle BAC, the large triangle which is that BAC, measure angle B plus measure angle BAC plus measure angle C should be giving 180. This is my triangle property, that is sum of all the angles of a triangle is 180. Out of that, B is X degree plus BAC, angle BAC is 90 plus measure angle C is equal to 180. I am getting these values from 1 and 5. Now I'll take X and 90 on right hand side. That gives me measure angle C is equal to 180 minus 90 is 90, and this plus X goes on that side minus X. So I got value of angle C is equal to 90 minus X. Okay. Now angle ADC, full was X degree. We have already put it up here, and it's equal to 90 degree. Angle ADC was 90. Okay. Now based on that, I have to find out measure of angle JDC. How will I get measure of angle JDC? Point number 7. Measure of angle JDC. Measure of angle JDC is made up of measure of angle ADC minus measure of angle JDA. ADC is 90 minus JDA. JDA, isosceles triangle, JDA, it was what? X. This I got from statement number 3, comma, and statement number 4. This is nothing but angle addition axiom. To find this small angle from the larger angle ADC, I have subtracted JDA. Okay. Now let's enter the triangle JDC. Point number 8. In triangle JDC, measure of angle JDC is equal to measure of angle C, and that too is equal to 90 minus X. So C is 90 minus X and JDC is 90 minus X. This I got from point number 6, 7. Now children, in triangle JDC, both the base angles are congruent. That is 90 minus X, 90 minus X. If I apply converse of isosceles triangle theorem, so what do I get is, therefore Seg JC is equal to, congruent to Seg JD. This is by converse of isosceles triangle theorem. Now, very important thing, just concentrate on this particular statement here and the last one. It's given JC is equal to JD. Say JC is congruent to JD, but JD is congruent to JA. So if I connect both these particular boxes with each other, JC is equal to JD and JD is equal to JA. So what will I get? Final thing is that point number 9, I'll get therefore Seg JC is congruent to Seg JA. This comes from statement number 4 and statement number 5. So that is nothing but AJ congruent to JC. That is what he's asking us to prove. AJ is congruent to JC.